Alright, in this example you have a traffic light weighing 122 Newton hangs from a cable tied to two other cables fastened to a support as the figure below. The upper cable make angles of 37 and 53 with the horizontal. Those upper cables are not as strong as the vertical cable and will break if the tension in them exceeds 100 Newton. Will the traffic light remain hanging in this situation or will it break? Alright, looking into this problem, it's definitely a 2D problem, and actually we went over some of the concept of these 2D problem. Let me just explain in the beginning. If you have a tension with an angle, it's been pulled with an angle in some direction, you're obviously possible to find Tx, and you're also possible to find Ty in this case. So Tx is always equal cosine theta, right? And Ty equal will be sine theta, and those are how you can define the two other tensions for x and y, comparing to the tension, the red one, which is the hypotenuse with an angle. And also we introduce if you have something it's hanging and not touching the ground and there is a tension, and if this tension been pulled upward, okay, your tension should equal mg plus ma. But if your tension is been pulled downward, okay, so this is upward, and if your tension been pulled downward, so in that case mg will be minus ma. So we look into this specific problem. We know that in 1D going upward and downward, it's a matter of mg plus or minus ma. Okay, let's go ahead now and try to solve this problem. First of all, we know that we have tension 2 and tension 1, they're both with an angle, so it is possible for us to draw an x-axis like this, okay, and it's also possible to draw a y-axis. So we can draw a y-axis and the x-axis based on the coordinate system. Now we can just go ahead and look into each one. So let's go and look into the x-axis. For T1, we have T1 x is heading toward the negative axis, and we have T2y is heading toward the positive y-axis. So those are the tensions that are located on the x-axis, and we can also draw Ty, and this is T2y. This is also heading upward toward the positive y-axis, and we have also T1y, which is also heading toward the positive y-axis. Also looking into this one, this one is been pulled down, so now we know that T3, this is also on y-axis, it's heading toward the negative y-axis, which means it's going downward. So this free body diagram will illustrate to us how can we build the F-net for x-axis and the Fy for x. Looking into now, nothing is moving, so they are into equilibrium, so we know that F-net x will be equaling 0 and F-net y will be equaling also 0. Okay, let's go ahead and do the problem. So remember, we have to start with F-net x, right? So F net x should equal minus T1 cosine 37, which is the one heading into the negative direction on the x-axis, plus T2, which is cosine 53, and that all should equal 0. So let's go ahead and try to solve this. So we can just move this to the other side. This will be T cosine 37 equal T2 cosine 53. So T1 will equal 0.75 T2, and this is our first equation for this one. Alright, so we managed to solve the F-net on the x-axis as it's in equilibrium, so it should equal 0. Let's go ahead and solve the Fy. So the F-net on the y-axis, okay, should equal T1 sine 37 plus T2 sine 53. They're both heading into the north, which both heading into the positive y-axis, minus T3 equals 0. T3 we know it's heading south, so that's heading toward the negative y-axis. So this is now we're constructing the equation for the F-net y. Let's go ahead and solve, but because before we solve, we can substitute this with that equation. So this equation will turn to be 0.75 T2 sine 37 plus T2 sine 53 equal 122. By substituting now, we have only one variable to solve for, which is T2. Now our life is much easier in this case. So this leads into 1.25 T2 equal 122 Newton. So T2 should equal 97.4 Newton, and that's the second part of our equation. Alright, so our final equation now, is it possible to take this equation 2 and substitute it with equation 1? Okay, so our final equation for this case, will be T1 equal 0.75, substituting T2, which is 97.4 Newton. So will lead into 73.4 Newton, and now I managed to find T1 and T2.